We all know about the crazy world of crypto, the meme coins, the NFTs, but behind the hype, there's something far more important powering the next generation of blockchain performance. Are you tired of slow transaction speeds, high gas fees, and a clunky user experience? The solution is not another meme coin, but the Solana Virtual Machine (SVM). This technology isn't just the backbone of Solana, it's a blueprint for the future of blockchain computing. Today we'll break down what SVM is and, more importantly, why you should care. The Solana Virtual Machine, or SVM, is the core engine that drives the Solana blockchain. It's responsible for processing transactions and executing smart contracts, also known as programs on Solana. Now you might have heard of the Ethereum Virtual Machine, or EVM. The EVM is what powers Ethereum and many other blockchains, but the SVM takes a radically different approach, designed for speed and efficiency. One of the key differences is how the SVM handles code. Instead of using the EVM bytecode, the SVM compiles smart contract code written in languages like Rust, C, and C++ into something called BPF, or Berkeley Packet Filter bytecode. This bytecode is highly optimized for speed, allowing Solana to process transactions much faster. But the real secret sauce of the SVM is something called Sealevel. Sealevel is a groundbreaking parallelization mechanism. In simple terms, it allows Solana to process multiple smart contracts at the same time. Think of it like this. The EVM processes transactions one after another in a single line. Sealevel is like having multiple lanes on a highway, allowing many cars or transactions to travel at the same time. This is a massive improvement in performance. Sealevel analyzes the data interactions of different transactions beforehand. If it identifies that they won't interfere with each other, it processes them in parallel, allowing Solana to handle tens of thousands of transactions concurrently. Another key advantage of the SVM is its localized fee market. On Ethereum, the fees are determined by a global fee market. When there's high demand, like when a popular NFT collection drops, everyone pays higher fees, even if they're just doing a simple DeFi transaction. This is because the high demand activity inflates the transaction fees for all operations. The SVM solves this with localized fee markets. Each smart contract has its own independent fee market. This prevents one popular application from spiking fees for everyone else. It's fairer, more predictable, and makes Solana much more accessible for everyday users. Think of it as a system where the cost of going to your local store isn't affected by a stadium concert happening across town. So with all that said, why should you choose SVM? Let's break it down into 4 key advantages. First, avoiding structural issues in Ethereum's fee market. As explained above, localized fee markets are a game changer in cost for users. No more exorbitant fees. Second, EVM performance bottlenecks. SVM is designed to execute multiple transactions at the same time. It will be a much faster, smoother user experience. Third, the overestimation of EVM's ecosystem advantages. The EVM ecosystem is extensive, but the SVM's vibrant and growing ecosystem with robust solutions is worth the change. Finally, the complexity of ZKVMs. SVMs provide the solution without needing to add complexities such as sophisticated cryptographic techniques and steep learning curves, and easier integration than other technology. Let's dig a little deeper into that first advantage. Ethereum's fee market. When minting an NFT becomes a popular process, this leads to a scenario where users have to pay exorbitant fees during times of network congestion, making the network less accessible and more expensive for everyday transactions. The Solana Virtual Machine, with its localized fee market, offers a solution to this problem by allowing transaction fees to be determined independently for each smart contract, thus preventing unrelated transactions from affecting each other's costs. The Ethereum Virtual Machine, or EVM, is inherently limited by its design, which processes transactions in a single-threaded environment. This sequential processing creates a bottleneck, limiting the number of transactions that can be processed simultaneously. As a result, during periods of high demand, the network becomes congested, leading to delays and higher transaction fees. In contrast, the Solana Virtual Machine, or SVM, leverages parallel processing, allowing it to handle multiple transactions simultaneously. This not only increases the throughput of the network, but also ensures that it remains responsive and cost-effective even during periods of high demand. So, to recap, the Solana Virtual Machine is more than just a technology. It's a new approach to blockchain computing. By implementing parallel processing and localized fee markets, the SVM solves key problems that plague other blockchains. As Solana's transaction speeds increase, the SVM's advancements position it as a formidable alternative in the blockchain landscape, catering to diverse user needs while prioritizing efficiency and scalability. As Solana continues to gain traction and more developers adopt SVM, we'll see a wave of innovative applications that were simply impossible before. Ready to learn more about the Solana Virtual Machine and the ecosystem that's built around it? Check out the links in the description below. You'll find resources for developers, information on Solana-based projects, and ways to get involved in the community.